Hi, this is Asphyxium, and welcome to How to Make a Master System Game using Devkit SMS tutorial number 4. In this lesson, we go over creating batch files that will compile our game code into an actual Sega Master System game. We go over creating the needed source code files for our project, and finally, we set up the main source file and define the game headers. Let's begin. Okay, first we're going to start off by making some adjustments from our previous video. One of the things that I forgot to export was the tile set for the title screen. So I'm going to go ahead and do that into our assets folder, title tiles. And then we're going to head back into Visual Studio Code to start actually coding. Another thing that I did that I didn't really mean to do was to export the import palettes. So I'm going to delete those. Okay, I think now everything is in order. Within our project, all those assets that we exported from the last tutorial are in here, and we're going to use assets to banks to create banks out of those resources. So we're going to create our first batch file by going to the banks directory and create a new file. I'm going to call this asset build.bat. Asset build.bat is a batch file. This is a special file within Windows that you can define things that can be executed within the file, like running programs and also doing some things with the directories. So we're going to use this, and we're going to call assets to banks through this batch file. So the first line here has to do with the batch file itself. This is a command that the batch file will understand. Echo off basically means that anything immediate here will not, any messaging won't show up on the terminal when we're building or doing anything within the batch file. And I'll show you what that means soon enough. This second line is just calling assets to banks. If you recall, in our first tutorial, we moved assets to banks from the Devkit SMS source code file to SDCC and a bin file over there, which is short for binary. So we have a reference to it that we can just call without any sort of pathing to it. So we can just call assets to banks here, and our first argument is where to find the resources for assets to banks to compile our banks from. And then the last argument here is to actually compile our banks. So that's what it's doing here on this line, and then the last line is just exiting out. So I'm going to save that. I'm going to come up here to terminal. I'm going to create a new terminal. As you can see down here, we're in the Miss Pac-Man root folder, but where we want this to be compiled, where the asset underscore build.batch file is under the banks directory. So we're going to change to that directory. So cd, change directory, and then we're going to put in banks, and that will put us into the banks directory where we can call asset build.batch file directly. So we're going to do that right now. So what's going to happen here is assets to banks is going to look in our assets folder where we have everything that we need for a game, all those binaries, and it's going to put them into 16K banks as optimally as it can, and then it's going to create some header files on top of that and REL files. But the header files will contain the constants that we're going to be using in our game code. So let's do that. Down here, put dot backslash, and then I'm going to call asset underscore build dot bat. And hit enter. Oop, misspelled it. Might help if I spell it correct. Okay, asset build dot bat, and you can see here that assets to banks was ran and that we requested some output, which we got, and I'll show you that. So over here you can see that some files were added, bank 2, bank 3, bank 4, and we'll go over those in detail. But you can also see there's some other information here that the output saying we created 3 banks, or assets to banks created 3 banks, generated on bank 2, there's a bank 3 and bank 4, and there's a little number that's in there for each one of those. And what that means is out of the 16K available for each one of these banks, the number that's next to the bank number is how much is left in that 16K that we could use. So there's 15 bytes left out of bank 2, and there's nothing left out of bank 3. That means we use the entirety of it. And in bank 4, there's still 11,008 left in this bank. So bytes free is what it's saying there. That's what that information is. And then if we go and look at the bank 2 header file, and this is what we'll be using within our code, there's constants that are defined, or macros. Basically, these are constants. So we can then in our code point to the actual binary data. So here with the sprite tiles binary that we created, it's telling us how big the data is. And if we take a look at our SMS Tile Studio, you can see that that sprite, when we exported the tile set as a binary, it was telling us it was 7,936 bytes, and that's what's shown here. So this will be a pointer or somewhere that we can say this is where our data is, and then here this is the actual bank it's in. So it's in bank 2, that's what we have here. And this last one is just the size of the data in bytes, so it's mimicking that number, and we'll be using that as we bank switch and use these resources within the game. Okay, I think that's all figured out. So we're going to create another file here, and we're going to call this one underscore compile run.bat. There's another batch file that we're creating, and what this one will do is it'll compile what source code that we give it, and then it will actually run the resulting game through Emulicious at the end. So first things first, we're going to again use the same line that we use in asset underscore build batch file. We're going to run assets to banks to get our banks. Then the next one that we're going to run is SDCC itself. I'm going to say just compile. Don't bring in the link editor or anything. That we're just going to create a compilation of the source code that we're going to give it. So, and then one of the options here that you can use is to optimize for speed. You can optimize for speed, or you can optimize for size. I'm not going to use this at this moment. This is something usually I put at the end. So in this first argument, it's saying, okay, use the Z80, and then we're going to hand it this peep file, the peep rules.txt that we have in the bank directory down here. And then we're going to hand it the main entry point for our game, which is main.c. So it can take all that source code from that point that has a main.c and build it. Next thing we got is another call with the SDCC. this O means the output, or what it's gonna create in the end, which is the Miss Pac-Man IHX file. This is saying again use the Z80. This is where we're saying not to use the standard CRT because we have one defined already in libs, this CRT0_SMS.rel, and then the it's just saying where the data location start is for this. Next lines are the mapper addresses for our banks. So it's 8,000, and then for whatever bank you are going to use, you're going to put that number bank in front of the 8,000. So if we want to expand this game going forward, and we needed another bank was created, so maybe we made some audio resources, or maybe we made some new graphical resources, or there's just new binary data to store and a bank, and then you would put your next bank number in, and you would put it in front of the 8,000, and so on and so forth. This character at the end, it's just saying that there's more information on the next line. Typically, we would have to put all these arguments for this call on one line, and the more you add, the more length is added to this one line, and to mitigate that so it's a bit more readable, you can use this character here to say there's more information on a new line. Okay, next thing is that we're going to point to where that CRT_SMS.rel file is for our CRT file, and then main.rel should be what it should be created by this call. So then we'll use that resulting file down here, and that's how we'll link this into project or the game. And then the next portion is to use these REL files that Assets to Banks has made for us. I'm going to link those as per what we have created. So we're going to put the bank 2 REL here, bank 3 REL, and that's where that comes from. So that's going to be part of the linking. And then finally, the last portion of this SDCC call is that we're going to link in our SMS lib, which is from Devkit SMS, that we put into the, if we recall, the SDCC folder under Z80, and then under the libs for the Z80 we placed this file there, so that's what it's calling here. And then here we're gonna grab our audio library, so that's at psglib.lab, and that's located down here in our libs. So again, we're popping up one level, and then we're going to libs, and then we're grabbing our psglib, which is our audio library. So that's all it takes for that command. And then lastly, we're going to call make SMS again, one of those binaries that we brought over from Devkit SMS into our SDCC binary folder, and we're going to call it here. So make SMS, what it's going to do is take our resulting file that was put together by SDCC here, this IHX file, and so that's one of the arguments is this IHX file. So we're going to hand it that file, and then we're going to tell it where we want it created in the end, which will just be in our banks folder, and it'll be our final resulting game or ROM, however way you want to look at it. So SMS, this will be the actual game that'd be created by this. So now that's all it takes for the compilation portion of it. That should be enough to make a game based off of your source code. But there's also some cleanup I like to do using the batch file. So here I would echo out that clean up the files much like things are echoed out here on the command line by Assets to Banks. And I'm going to clean up some of the resulting files from all this compilation. So like SDCC, it'll make additional files, and instead of cluttering up the banks with a whole bunch of files that I don't really need, I'll clean them up here. This one here at the end, the ASM file, which is the assembly file, that SDCC is one that's very interesting. So you may want to keep that around. What that will be is the assembly, the Z80's assembly version of your C code, and sometimes it makes sense to go and take a peek at it if you want to see how SDCC translates your C code into the resulting assembly code, which typically when you write a Sega Master System game, it's in Z80 assembly. This converts our C code into that assembly language, and you can get some insights, learn a bit more about assembly. I have done this on occasion just to see what it would do. Also, when there's issues, sometimes I'll go and see if it did anything wacky with the registers. And I have run into this a couple times. Mainly, I found myself getting in trouble when I was using conditionals that were ternary or inline or shorthand. I shouldn't say inline, shorthand. I noticed one time I wrote something that was a conditional that was shorthand, and when I went to compile, which I'll often do, I'll compile just to compile to see if any errors show up or if the size of the ROM went up drastically. And there was a case where I had this conditional, and I noticed that for whatever reason it used up 1,000 bytes of the 32K that we discussed was for the code. It used 1,000 bytes, and I was like, I was mystified by that. So I had to take a look at it, and I don't know what it was doing, and there was bananas. So, and then I wound up rewriting that conditional in a traditional if-else statement, which cleared up. Then it only used 2 bytes or whatever. A little bit more than that, but it wasn't 1,000, so it fixed that. So there are some caveats to using C. Sometimes SDCC will interpret your code in a less than efficient manner. So sometimes it pays off to take a look at the ASM, especially if you see some discrepancy like that. All right, and then the last thing, after it cleans up all those additional files from compilation, we're just going to call Java, and we're going to call Emulicious. So if you recall, we put Emulicious in down here where we have it in our actual project. So what it'll do is it'll execute this emulicious.jar file, which is basically the executable. So again, it'll go up one level, go into Emulicious, and then it will call Emulicious, and then you can hand Emulicious a argument, when our argument here is our Miss Pac-Man game. So after it gets done compiling, it will actually run the game, and you can test it. And then the last batch file we're going to create here is just going to be a copy of compile_run. This is going to be compile by itself, so we're going to create that new batch file. I'm going to call it _compile.bat, and all it's going to be is compile run without Emulicious. So it'll just build. I'll show down here in our terminal or our console output, and that's all it will do. It won't actually take the resulting game and then actually run it through Emulicious. And there are times that I don't want to do that, so it's just another option there. I think there's actually one thing that I'm missing here. I didn't take notice it till now. I'm going to put this line in here as another batch file command, where all we're saying is if there was any errors that happened at this point, we're just going to jump to the end of the file EOF and a file, and then get out of the actual batch file. So forgot to add that in there. I'll add that on both these files. So we're going to create our source files. Typically in C you would have a header file, which would define your prototypes, and then you would have a C file that was accompanying that header file that the implementation would be. For this tutorial, we are not going to have any C files defined. We're just going to do everything within the header file. So I'm going to start creating that structure. And the first thing we're going to bring in is the audio.h file, which header that's going to handle running our audio tracks. And then we're going to bring in bonus.h, which has to do with the bonus entity that shows up in the game. Common.h, common functions that we'll be using in the game. Defines.h, this is where we're going to put our defines, our macros, our C macros. And see what we got here. Entity.h, functions that deal with entities as a whole, so that could be anything from the player to the ghosts to the bonus and any of the cut scene logic. Game.h, which is the top level portion of the game that handles the game state specifically. Ghost.h, any functionality for the ghosts. Globals.h, this is where all our global variables will be held for the most part. That's the portion of RAM that we discussed previously, that 8K worth of work RAM. We're going to keep all our variable logic or global variables in there. HUD.h, the heads up display, so this will be where the score is being changed and where the player lives are shown at the bottom, and the current bonus that we're at, the bonus level at the bottom of the screen. And then we will put in our actual entry point, which will be main.c. Player.h, all logic for the player or players. And then each one of the scenes that are in the game. So where Junior is introduced, this is where Pac-Man, Miss Pac-Man are chasing each other. And this is when Pac-Man, Miss Pac-Man meet each other, that scene. And then we have two more here, stage. .h, this is where the main game logic is ran from. And then at the end we have title.h for the title screen. And I believe that's everything we need there. So we're going to do one more thing here in this video, and we're going to set up the main.c, our entry point for the game. And we have a bunch of header files that we need to include into our code to use. And the first two are the libraries we're going to be using. So we're going to, this SMS lib.h is supplied to us through Devkit SMS. We're going to use all the functionality from this library later in the game, you'll see. As well as the other library that we're using is the audio library, the PSG library. We'll be using that later in the game as well. The other things we need to do is bring in our resource files that we can reference later, which is the bank 2, bank 3, and bank 4H, like I showed previously. They have a bunch of constants that we'll be using in the game, so whenever we want to load those resources in, this is where we're going to get all the information by including it in our game code. And the next one we're bringing in is string.h. This is a included C library that we're going to use that's part of the SDCC C library. The only reason why we're bringing this in is so we can use a function that it provides a memory copy function. We're going to copy bits of our, or bytes of our RAM from one section to another, and you'll see that as we go along. And then finally, we will bring in all the header files or source files that we have already defined. So those ones we just created, we're going to bring into this project. So we have to do it in a certain order. For instance, if I had globals below everything and any of these other source files would use a global variable, it would tell us in the compiler, it would error out and say, well, it can't find whatever was defined here. So if I have like a global variable that was keeping track of the current stage we're on, and I had it at the end here, none of these other source files could reference that stage variable because it needs to be defined before it is used, and that goes for functions as well. So any kind of functions that are in these source files, if it's created after it's being used by another source file, it won't work. You have to have it in a certain order that it is defined first before you can actually use it. And then we have the almighty game loop. So let me comment some of this stuff out that we don't have yet defined. So this is the main entry point for the game. Void means that it doesn't return anything. Some of the functions that we'll use return a value, and then void as a parameter or an argument means that we're not passing in any sort of argument or parameter to be used within our code block, which is defined by these curly brackets. So everything within this block is what this function would handle. So this is the main entry point. This is a for loop. Typically you would have some conditionals here for the for loop, and basically all the for loop does is between these brackets it will run these functions over and over and over again. In this case, forever. Typically you can put conditionals in here where you only run the for loop X amount of times, but in this scenario we're running it for forever. We're basically saying this will run continuously. This game loop will run until the system's shut down. And one of the first calls we make is from SDCC. They're usually prefixed with this SMS in front of it, underscore, and the first thing we're doing is waiting for the vertical blank before we do any sort of processing. And I'll go into more detail later on what that means. And then lastly, there are some provided macros, again, from Devkit SMS. Here we define our product code, which is a numeric of some sort. Should be unique. I use 777. I don't know if that's unique or not, but considering it's a tutorial, I'm not really all that concerned. The revision number, right now it's going to be 0 because there is no revision of this game. There's no game out yet for this. And then the second one is the SDSC header embedded, where we have the major version portion, the minor version. So here would be 1.0 with the 1 and 0, the date year, the day, the month portion of the date, and the day portion of the date that we're saying this was created. Then you have the author, which is me in this scenario, the name of the game, and a description of it, which typically is genre driven, so action. If you have action game, RPG. If it's RPG, shoot 'em up, whatever you may want, like maybe use a light gun or game or something of that nature. Then you put that information here. And I think that's everything for this lesson, and hope you enjoyed it. And the next one, we'll be going over the beginning of our source files, and we're going to start most likely with the defines. So I'll see you then.